Welcome to this video in which we will be continuing with Unit 2 of National 5 Chemistry, Nature's Chemistry. We're going to be moving on to Unit 2, Topic 2, which has the title Everyday Consumer Products. Really though, this topic is going to focus on the chemistry of alcohols and carboxylic acids. These classes of chemicals are important in nature, but they are also important in several products that we can buy in the shops, which is why this topic is called Everyday Consumer Products. When you're listening to this video, you're going to need to take notes and answer some questions. All you'll need is a pen or a pencil and a jotter or paper to write your notes and answer your questions on. I'm going to begin by just explaining where we are in the course. So we have completed Unit 1 as you know, and we've done a couple of assessments on that. We're now on Unit 2, Nature's Chemistry. We've completed Topic 1, which was on hydrocarbons. It's also called the homologous series topic on BBC Bitesize. We've also completed Topic 3, Energy from Fuels, although we did that over a couple of different lessons at different times. So this is the final aspect of this unit. Once we finish this unit, we will be doing some assessments on Unit 2. Topic 2, like I said, involves studying alcohols and carboxylic acids. This week we're going to complete the work on alcohols, and next week it will be moving on to carboxylic acids. This slide shows you the learning intentions for the alcohol family part of the everyday consumer product topic. So we're going to be learning about a homologous series called the alkanols. It's very similar to studying the alkanes and alkenes. What we need to be able to do is identify an alkanol from the hydroxyl group, which is a new group that you haven't learned about, and the ol name ending. We need to learn how to name straight chain alkanols, incorporating the position of the hydroxyl group from shortened and full structural formulae. And we need to be able to state the chemical and physical properties of the alkanols and the general formula which shows that the alkanols are a homologous series. You also need to be able to give examples of the uses of alcohols, and this will be covered in the final part of the video. So what do you know already about alcohol? I'm guessing the pictures on this slide will probably be familiar. You most likely have heard of alcoholic drinks, and you may know that alcoholic drinks are associated with some medical problems if consumed in excess. In this day and age, we're all aware of hand sanitizer, and you might have known that hand sanitizers contain alcohol. You might also know that alcohol is flammable, as can be seen from this picture of a Christmas pudding being set nicely on fire. The alcohol found in alcoholic drinks is called ethanol. We can also refer to this as common alcohol. It's the most common one that we come across. On this slide, you'll see different representations of the molecular structure of ethanol. On the top left, you have what we would call the ball and stick representation. This is a bit like how the molecule would look if we built it with the Molly mods. To the right of that, and in the middle of the slide, you have the full structural formula of ethanol. On the far right, you have the molecular formula of ethanol, and then on the bottom left, you have the shortened structural formula of ethanol, CH3CH2OH. These different representations are similar to the way we could represent the alkanes and alkenes in the previous topic. The difference that you'll see with ethanol compared to the alkanes and alkenes is that ethanol is not a hydrocarbon because it also contains an oxygen atom. More specifically, we would say that ethanol contains the hydroxyl group. The hydroxyl group is an oxygen bonded to a hydrogen, as you can see in these structures. You might be asked in an exam to circle the hydroxyl group. So make sure you copy these structures down and circle the hydroxyl group and label it so that you could do this in future. You don't really need to copy down the ball and stick diagram, but you can if you want. So as I say, the OH group of atoms is called the hydroxyl group. You might hear me call it the OH group. It's called the functional group as it gives the molecule the chemical properties of an alcohol. So in substances, sometimes there's a particular part of the molecule which gives it certain properties, and the part of a molecule which gives it certain properties is known as a functional group. And we would say that alcohols have the hydroxyl functional group. The name ethanol tells us quite a bit about the molecule itself. It has the prefix eth, which means that ethanol contains 2 carbon atoms. The "an" part of the name indicates that ethanol contains a single carbon-to-carbon bond, otherwise it would be ethanol if it was a double bond. And then the "ol" ending tells us that it contains the hydroxyl functional group. Ethanol is a member of a family of alcohols called the alkanols. The alkanols are a homologous series of alcohols which contain only single carbon-to-carbon bonds and only contain one hydroxyl group. This slide looks at the properties of ethanol. We're going to look at the properties of the alkanol homologous series in general later in the presentation, so you don't need to write down the information on this slide. However, I would like you to have a little read through. Pause the video now and have a read of the information on the slide. You now have a task to do. Write a word equation and a balanced symbol equation for the combustion of ethanol. You'll need to remember what is meant by combustion and what the products of combustion of ethanol would be. These are given on the previous slide. Pause the video now and attempt this question. If you are stuck, I'm going to go through some hints over the next few slides, so you can keep listening, but I'd rather you pause it now and try to do this yourself. If you're listening to this, I'm hoping you've already tried the question. You can listen to me going through the answer, but if you were stuck, you can also listen in for some extra help. The word equation for combustion of ethanol is given on the slide. Combustion means reaction with oxygen, so the two reactants are ethanol and oxygen. They change into carbon dioxide and water. This information was given in the previous slide. If you didn't get the word equation, then you can write this down now, but I would like you to try now doing the balanced symbol equation for yourself. On this slide, I've written the symbol equation for combustion of ethanol, using the molecular formula given earlier in the video, as well as the molecular formula for oxygen, carbon dioxide and water, which I would expect you to know. When you're balancing this equation, remember you first need to count the number of each type of atom on each side. I would recommend balancing carbon and hydrogen first. So try and do that now by pausing the video, and then we'll look at the answer in the next slide. Okay, so to balance the carbon, then you should have recognised that there are two carbons on the reactant side of the equation and put a 2 in front of the CO2. To balance the hydrogens, you should have counted 6 hydrogens on the reactant side and then put a 3 in front of the H2O to balance the hydrogens. Now that we've done that, we have to recount the number of each type of atom. What we find is that we have 3 oxygens on the left-hand side and 7 oxygens on the right-hand side. Now see if you can balance the oxygens. This is a little bit tricky, but I'd like you to have a go. So to balance the oxygens, what we needed to do was put a 3 in front of the O2. Previously we had 3 oxygens on the reactant side and 7 on the product side. We have 1 oxygen in the ethanol, so if we add 3 in front of the O2, that gives us 1 oxygen in the ethanol plus 6 oxygens from the O2 molecules, which gives us 7 oxygens altogether on both sides now. I hope you got on okay with the balanced equation. We're now going to look at 2 different ways of making ethanol. On this slide, we have the reaction that is used to make ethanol in the alcoholic drinks industry. I would like you to write down the sentence, but you don't need to write down the reaction because it isn't a mandatory thing for you to know at National 5. Ethanol is made in the alcoholic drinks industry by the fermentation of sugars. Glucose is an example of a sugar, using the enzymes in yeast. For those of you that don't know, enzymes are biological catalysts that carry out the chemical reactions in all living things. Enzymes convert glucose into ethanol and carbon dioxide. In addition to fermentation, ethanol can also be made in industry using ethene as a feedstock. So ethanol, or industrial alcohol, that's what we call it when it's made in industry rather than by fermentation, is made in the petrochemical industry by adding water, or steam, to the double bond in ethene. This reaction is called hydration. This is one that you definitely need to know at National 5, and we did learn about addition reactions when we did the hydrocarbons topic. But just to be sure, make sure you write down the sentence and copy out the equations for this reaction in your notes. We've mentioned already that ethanol is a member of a homologous series of alcohols called the alkanols. This slide shows the first three members of the alkanol family. Just like with the hydrocarbons, the member of the family with one carbon atom is known as meth, and it's known as methanol because it's an alkanol. With 2 carbons it's ethanol, and 3 carbons is propanol. If you take a look, you can see the way the full structural formula and the molecular formula are written for the alkanols. Notice that in the molecular formula we write the hydrocarbon part of the molecule and then we write the OH group at the end. This is just to make it clear that these molecules are alcohols. If you count up the different carbon and hydrogen atoms, you will see that the alkanols have a general formula of CnH2n plus 1 OH. Again, we could write CnH2n plus 2O, but we write it like this just to make it clear that these are alcohols, because this shows the OH, or the hydroxyl functional group. You may have already written down from the previous slide some information about the first 3 members of the alkanol series. On this slide, it asks you to copy and complete the table into your notes for the alkanols containing 1 to 6 carbon atoms. You don't need to repeat the information on the previous slide, but I would like you to make sure that you have the name, molecular formula, full structural formula, and shortened structural formula written down for the alkanols containing 4, 5, and 6 carbon atoms: butanol, pentanol, and hexanol. When writing the shortened structural formula, use the example in number 2 in this table as a guide. It's very similar to writing the shortened structural formula of In this slide, we're going to look at the systematic naming of alkanol isomers. Alkanol molecules form isomers, therefore the name has to describe the structure. Remember, isomers are molecules with the same molecular formula but different structures. The naming rules learned for the hydrocarbons apply, except the molecule name ends in "ol." For example, we could have isomers where the position of the hydroxyl group differs. As seen in this slide, you could have propan 1-ol, where the hydroxyl group is on carbon number 1 in the chain, or you could have propan 2-ol, where the hydroxyl group is in carbon 2 of the chain. You can see how they are named differently, and the shortened structural formula would also be drawn differently. This is given at the bottom of the slide. We can also have branched alkanols. Technically this isn't part of National 5, but it's worthwhile for you to know anyway, and you can see the example on here, 3-methyl-butan-1-ol. Make sure you copy down all of the structures on this slide, as well as their names and shortened structural formula, as well as writing down the steps to name an alkanol. You should have already written down some examples of how to name different alkanols. In this slide, this is a practice question. You have to copy the structures, name each alkanol, and write the shortened structural formula. Pause the video now and attempt to answer this question. Here are the answers to the question. The first one was butan 2-ol, and it has the structural formula shown on the slide. The second one was heptan 3-ol, and again you can see the shortened structural formula on the slide. When checking your own shortened structural formulas, pay close attention to the fact that when the hydroxyl group or the OH group is within the chain, we put it in brackets. Also pay close attention and double check the number of carbon atoms that you've drawn in your shortened structural formulas.